Hello and welcome to the latest in this series of podcasts from Croda as part of our Beyond Boundaries campaign. This campaign looks specifically at innovation and how it permeates throughout the whole organization, how it impacts people who work here, how it impacts customers, how it impacts our partners. And we're looking at real examples on each of these podcasts about where that innovation has come from and how it's manifested real impact across the organization. We've got a really good example today. It's based around the concept of continuous reactor technology. We've got some great impact numbers associated with this, and we'll come to those in a little bit. To talk us through this, I'm joined by Dr. James Burbeck, Process Innovation Manager at Croda. Hello, James.
Hello, Richard. It's a pleasure to join you on this podcast, and I'm looking forward to talking about some of the work that we've been doing at Croda.
Well, this one sounds particularly interesting just because of the scale of the impact it's had. And as I said, we'll come on to that in a second. But first of all, I mentioned in the introduction continuous reactor technology. So just talk us through what we mean by continuous reactor technology and why it's different to kind of batch reactor approaches in the area that Croda works in.
Yeah, so batch reactor technology and the way it operates is quite commonly used in industry, particularly in our area of specialty chemicals. It has a lot of flexibilities. Essentially, you load materials into a process, you do your transformation, and then you empty it. This has some advantages in being able to manipulate those materials in different ways within that process. But we've been looking at enhancing our processes and making them more efficient by moving to intensified processes, and in this case, a continuous reactor technology, which enable us to manufacture materials in a flow regime, thereby enabling us to put material in at one end, do the transformation, and empty the other end, all at the same time, saving a lot of time and improving efficiency compared to a batch process.
So this was obviously something that Croda wanted to look at for a particular reason. Was this driven by customer request or demand, or were you finding that simply the amount of work that needed to be done, the amount of material that needed to be produced, was getting higher and higher?
We can talk about the customers in a minute. I think initially this particular project started with a real need because there was increased demand from customers for material. So Croda was at a point of choosing whether to use the same technology we had already or to look at an alternative methodology and gain some of the advantages that could be delivered through a continuous process. So we started a review and identified a technology that could allow us to scale up continuously to deliver more product quickly to our customers. The technology itself has some big advantages for customers, particularly around our ability to vary the batch sizes that we produce, and also to enable a higher level of consistency of product because we can turn on the unit, make it run for a long period of time, and deliver consistent product. As customer demand varies, we can also increase or decrease the speed that the reactor produces material to enable us to keep up with customer demands as they come online.
So yeah, it sounds like it provides quite a lot of flexibility, but that consistency is obviously critical for customers, especially if they're producing or they want to produce high volume um, products that rather than low volume products. They want to make sure everything's the same. So I assume we're talking mainly here about sort of consumer care customers.
Yeah, absolutely. So it's mostly consumer care customers that take materials from this particular process, and they really are looking for a consistency of product where part of the value offering that Croda delivers is that consistency, high quality of product that can therefore give them the certainty that they are able to manufacture their materials for end consumers consistently and on time when they need it. Um, and this process really enables Croda to be more flexible and meet those customer demands when they need them.
Okay, so it's a new technology for Croda. Is it a technology that has been out there in a different part of the market or the same part of the market? How did you come across it? Is it a brand spanking new type of technology, or was it in use somewhere else that kind of gave you the idea to bring it into Croda?
I think it's fair to say that continuous processing as a concept is not new at all. The industry has been using that for many decades, but usually that tends to be on high volume, single product lines where you are aiming for a very high levels of efficiency and unit operations running sequentially one into another. The challenge for Croda is that actually we need to be able to produce different materials down the same product lines, be flexible in terms of our flow rates and speed of operation, and linking in continuous assets to potentially assets that aren't continuous batch type assets or other types of processes. And this the technology's really moved on in the last few years that has enabled Croda to intensify processes in a scale and with the flexibility that really enables us to deliver the products that we need to produce to our customers when we need them. So, yeah, this is a new type of technology per se to Croda. It isn't brand new to the industry. There are other industrial examples where these have been scaled up, but they are quite limited at this point in time. So we're not necessarily first to the market in this case, but certainly this is one of the first examples where it's been used in a specialty chemical type environment.
Okay, interesting. And is this something that you identified as an opportunity on your own, or was it done through some kind of collaboration with others?
So Croda initially identified the technology and the potential for it and did some work on our own to verify that there was potential in it. We then sought out a collaborative way of working with a collaborator that would enable us to scale up. They also then brought in the technology provider and an academic institution as well to enable us to get a broader understanding of how the technology could be delivered, to enable us to scale up efficiently, and also give us a better understanding of what impact this would have on our business and really how our business needed to change to enable this type of technology to be utilized to its full extent.
And, and and did the business need to change much to be able to implement it? I obviously I'm aware that you're kind of not at the center of the operational side of this, but did the business have to make many changes in order to use this technology?
Think one of the biggest changes, Richard, was the thinking around how do we operate with a more continuous type process and how does that impact all of the other aspects around the process itself. So this could include things like supply chain, where if you're used to a batch process, you know very well that you have a certain amount of material being used on a certain schedule. Whereas the continuous process, you can vary that speed and the material needs to be flowing through the reactor to make it efficient continuously, and therefore you can't afford to run out, and you have to make sure that you have material on stock all of the time when you need it. So that does present some challenges as a supply chain end. And at the other end, of course, you need to make sure that you have enough storage or utilization of that product so that it is then moved out of the post-processing vessels to ensure that you don't stop your continuous part of the process. So that's from a practical operational side. And from a business side, really understanding the value that this gives to our customers and other sections of Croda, which enable us to deliver something that is unique in that regard compared to the offering that we had before.
Okay, so what I want to do now is I want to spend a bit of time looking at the impact of bringing this technology in, because some of the numbers here are quite amazing. So let's look at the first one I would like to look at is the kind of carbon saving. So my understanding is that the annual carbon saving here as a result of bringing this process is over 86 tons equivalent. So that's my understanding is that that is like charging up electric cars or charging up an electric car about 9,000 times. This is significant, isn't it?
Yeah, this is a very significant, proportion of the carbon utilized for this process. And it's worth bearing in mind that this is just one single process on Croda's portfolio of a number of different processes. So if we could apply the same principles to other processes, it'd be a very significant number. Croda has some stretching ambitions for decarbonisation, and that's in line with the industry expectations and really what our customers are asking for. And it's clear that the further we share this with our customers and other peers, there's real interest in what we've done here. And our customers are very keen to not only understand what we offer in terms of the product, but actually how we've made it and making sure that what we've done is, as environmentally friendly as possible and give something a bit extra compared to perhaps other manufacturers in the industry. So yeah, this is a significant amount of carbon for this one process, but it certainly can be rolled out into other areas.
Because customers are really looking to you to guide them to a certain extent, because you're part of their supply chain. They want to see these types of savings. They must be pretty delighted with how this plays out from a sustainability angle.
Yeah, absolutely. And this is, I mean, for Croda, this is a scope 2 saving. But for our customers, that really means it's a scope 3 saving from the raw materials that they are supplied from us. So by delivering our carbon savings, we're passing those on to our customers and ultimately the end consumer as well. And we're obviously part of a larger problem here in the industry where we have a need to decarbonize and make sure that we're becoming more environmentally friendly. And Croda has signed up to the science-based targets to make sure that we are doing what we can to keep global warming to below the 1.5-degree rise, where environmental scientists are suggesting that there would be significant problems for the world.
Okay. And it's not just carbon that this approach has saved, it's water as well, isn't it?
Yeah, there's a huge amounts of water being saved here, and that's around 360 tons a year of water, which is again pretty significant. And a lot of this water that's been saved is by our ability to continuously produce and not need to wash so much between batches. And this water would be cleaned up before it re-entered the environment. But that amount of water saving, particularly if it is an area of the world where water is scarce, this is particularly important to try and reduce our, again, burden on the environment.
And just to put that into context, I mean, 360 tons of water a year is huge. My understanding is that you guys have done some fairly straightforward calculations, but suggested that that's like filling, 4,500 bathtubs full of water. This is a massive, just by bringing in this technology, this is an enormous change, and it hasn't just affected water and sustainability through carbon habitat. It's actually reduced the amount of time it takes to deliver end ingredient.
Yeah, absolutely. And as I mentioned before, the concept of running a continuous type of process means that you can sequentially, you don't have to sequentially go from filling, reaction, emptying. You do all of these at the same time. And that means really our cycle times are down from around 10 hours to material entering the continuous reactor to exiting it being around 2 minutes. Now, clearly, we'd take a little bit longer to make a batch, but it does give you an idea of how much time material is sitting around in a batch type process.
It's a significant shift. I mean, 10 hours to 2 minutes thereabouts is enormous. You must be really, really pleased having helped to implement this technology to see it delivering such fantastic results. Does it take up a lot of space to these big pieces of equipment?
The equipment itself is quite a lot smaller than our existing batch process. There's a lot of extra auxiliary equipment around it, um, but we reckon it's around 66% smaller in terms of the footprint. But one of the other significant aspects of that is that the footprint itself can be confined to a single story instead of the current batch reactor being around 3 stories. And that also makes a big difference in terms of the building materials used. So a lot less steel, a lot less concrete to support the floors, etc., which means you also reduce your carbon impact on the construction phase of the project as well.
I mean, this is kind of a perfect example, isn't it, of sort of smart, innovative thinking and technology delivering hugely scaled impact in multiple different areas. So, in terms of an example for an innovation campaign like Beyond Boundaries, it's pretty perfect. And I assume that the feedback from sort of customers and from the business as a whole has been pretty positive so far.
Yeah, absolutely. And customers are increasingly looking to see Croda as an innovator, not only in our products that we produce, but also the way that we produce them. And this is a great example of how we are taking innovation not only at the product level, but also at the process level to deliver benefits once we scale up materials to ensure that we have safer processes, less likely risks from the chemicals point of view, and also hazards to the operators working on them. As we mentioned, lower water, decreasing the actual waste that we produce, and therefore lower impact on the environment. Where we can, we'll look at improving atom efficiency to really utilize the materials that we're putting through the processes as best as we can. And overall, this has a great impact if you would scale this out and roll it out across the organization and other organizations as well in the industry.
I mean, it is also a really good demonstration that when we talk about innovation in a business like Croda, it doesn't just happen in the lab. It happens within the manufacturing process. It happens in the operational side of the business as well. So it's a wonderful example of innovation for the organization as a whole, which is a really important part of demonstrating how innovation kind of permeates the whole business. Dr. James Birkbeck, thank you very much for your time talking us through that. It really is one of the best examples that we've seen on this series so far. For anybody listening who would like to hear some of the other examples that we've used in this podcast series, you can download all of them from the Croda website under the Beyond Boundaries tab as part of the innovation section of the navigation bar. Have a look and download some information if you want to know a little bit more. For now, we'll say thank you, James. Really appreciate you taking us through that.
Thank you, Richard. It's been great talking to you today.
And we'll see you guys soon. Thank you very much.